The first photos from the Euclid telescope. The European Space Agency has published the first photographs taken by the Euclid telescope, which aims to search for dark matter and dark energy. The photos show the potential of the observatory and present spectacular images of nebulae, distant galaxies and globular clusters. The Euclid mission to study dark matter and dark energy was launched on July 1. During this time, the observatory traveled to the second libration point, also called the second Lagrange point, which is where the James Webb Space Telescope has been located since January 2022. It is a place where the gravitational interactions of two bodies, in this case, the Sun and the Earth, cancel each other out, so the objects there can remain almost motionless, which significantly facilitates observations. The main goal of the mission is to understand the nature of dark energy and dark matter by accurately measuring the accelerated expansion of the universe using various independent methods. In early August, Euclid reached point L2. During the startup phase, it already sent the first photos showing its capabilities. But then specialists emphasized that they did not reflect the observatory's full potential. Now, scientists managing the mission have published 5 photos taken after equipment calibration. They show 2 nearby galaxies, a gravitationally bound group of stars called a globular cluster, a large cluster of thousands of distant galaxies, and a nebula, all in color. Scientists also admitted that after the startup period, the observatory is operating efficiently, as expected. Euclid Observatory will unlock a treasure trove of scientific discoveries that will be used around the world for years to come, said NASA's Nicola Fox. NASA and ESA are jointly paving the way to a new era in cosmology for the upcoming Nancy Grace Roman Space Telescope, which will build on the knowledge discovered by Euclid and additionally explore objects at the edge of our solar system, discovering thousands of new planets, exploring nearby galaxies and beyond. Only, she added, during its planned 6-year mission, Euclid will create the most extensive 3-dimensional map of the universe yet, covering almost a third of the sky and containing billions of galaxies up to 10 billion light-years away from Earth. There are about 2 billion galaxies in this area, which will be better understood thanks to the telescope's scientific equipment. Euclid differs from other observatories in that it has a wide field of view, which allows it to take images covering a relatively large area. Telescopes like the James Webb Space Telescope focus on a smaller area of the sky, but typically offer much higher resolution images. The Euclid telescope has a primary mirror with a diameter of 1.2 meters and is intended for observations in the range from visible light to near-infrared. It has a camera for recording visible light, called this, a near-infrared spectrometer, and a photometer for determining the redshift of detected galaxies, NISP. The observation area is to cover as much as 15,000 square degrees, or more than 1/3 of the entire sky. For comparison, the full moon occupies about 1/5 of a square degree in the sky. The Euclid telescope weighs 2 tons and its dimensions are 4.7 meters high and 3.5 meters wide. The mission is a huge joint project. The consortium itself that proposed it consists of over 2,000 people, scientists and engineers from 15 countries. Its cost is approximately €1.5 billion. The observatory was created to study dark energy, the mysterious factor responsible for the accelerating expansion of our universe. Gravity should be pulling everything in the universe together. But scientists are seeing that instead everything is moving away from each other at an ever-increasing rate. To study dark energy, scientists intend to map the presence of another cosmic mystery: dark matter. Although no one has ever observed it, its existence is revealed by its gravitational influence on ordinary matter such as planets, stars and galaxies. Dark matter is abundant in space. Scientists estimate that there is 5 times more of it than visible matter, which constitutes only 5% mass of the universe. So if the influence of dark energy on the universe has changed over time, this change will be visible in the way dark matter is distributed on large scales in the universe. And the 3-dimensional map created by the Euclid telescope should be able to capture this. Dark matter is thought to hold galaxies together and act as the glue that holds them together. However, dark energy, researchers believe, accelerates the expansion of the universe. This means that leading cosmological theories treat dark matter as an element that slows down the expansion of the universe, and dark energy as something that constantly accelerates it. However, despite years of searching, the existence of dark matter and energy has not been confirmed. Scientists are still trying to figure out their exact nature. The Euclid mission is intended to change this. The first images from the Euclid telescope mark the beginning of a new era in the study of dark matter and dark energy, said Mike Seifert from the team that manages the mission. This is the first space telescope designed to study the dark universe, and the sheer scale of data we will obtain from it will be unlike anything we have had before. These are great mysteries. So it's exciting for the international cosmological community that this day will finally come, he added. Because observing distant galaxies allows us to go back in time. Astronomers will be able to analyze how dark matter evolved. This will provide insight into the interactions between dark matter, which binds galaxies together, and dark energy, which pushes them apart.